source. Check.
Check.
Okay, I got audio.
Okay, I got audio.
Okay, good evening.
Okay, good evening. Okay, good evening. Okay, good evening.
All right, folks, so it looks like this is up and running.
All right, folks, so it looks like this is up and running. All right, folks, so it looks like this is up and running. All right, folks,
And I have feedback, so I need to fix that.
and I have feedback, so I need to fix that.
Let's see. Does that make it any better?
Does that make it any better?
I am getting feedback. I'm not sure how to deal with that.
I am getting feedback. I'm not sure how to deal with that.
Okay. Concurrent viewers, 1.
Okay. Current viewers, 1.
Yeah. Okay. Okay. So it's 7 o'clock, and this is Crevasse Rescue. My name is Doug Latimer, and I'm your presenter tonight. Just like to check, folks, the chat is up and running. If you would be so kind, just let me know that the signal is coming through clearly, and you're picking me up. Good evening. How's everyone doing? Currently, it looks as if there may not actually be anyone watching online. So if people have tuned in, please use the live chat. Just let me know you're in. And, oh. I can't read it. But there is someone here. That's hopeful. Thanks. All right. So I'm going to get started. And you just let me know using chat if you're having any issues or if you have any questions. The system's probably running at about 60 seconds or so slow. And that basically means I'll see your questions about a minute after you hit the send. But good evening, and I'm going to talk a little bit about crevasse rescue. And crevasse rescue is actually one of those things that's changing quite a bit in the last few years because we've started to learn things that are quite a surprise. We're not following currently best practices because we discovered what we used to be doing wasn't really as good as it should have been. But let's get started. If you enjoy traveling through the mountains, at some point in time, you're probably going to need or want to cross a glacier. If you like skiing, some of the best terrain is on glaciers. And there's a lot of uncertainty about best techniques and probably the best approach to moving across a glacier. And there's a lot of things we don't really have nailed down. And part of this is because we don't have a national glacier organization. I mean, when you think about it, we have an avalanche association, we have a guiding association. So we have guiding standards, we have glacier standards, but we don't really have a really good solid protocol for moving on glaciers. And when you look online, there's a lot of different sources, a lot of different videos. Even some of the companies have got specific recommendations based on their equipment of current best practices. And yet, if you sit down and you go through them, you'll actually find there's a fair bit of uncertainty when you're looking at glacier travel and crevasse rescue. So what I'm going to do is I'm going to go over basically an effort made within the Alpine Club of Canada to try and set best practices. This is based on the standards of the Guiding Association, so the Association of Canadian Mountain Guides, and then also just doing my own research. And during COVID, especially during the first lockdown, I had a fair bit of time to start testing some of these theories and finding out what really does work and what really doesn't. So what you're going to be seeing is the work that I'm doing largely through an ebook that I'm in the process of making. And it's not finished. I keep thinking I'm going to have it finished in another 2 weeks. And of course, I get really busy, so I don't quite get it done. But it's coming. And it's starting to look pretty good. What really surprised me, though, was going through this was just how much we didn't really know. Okay? So don't get too worried if what I'm saying doesn't necessarily make sense. Just take my information, compare it with what you know, and by all means do your own work and your own research. But as I've said, we're all over the map, and it's time to start bringing down some standards that everyone is comfortable with. So the first thing we need to look at is the rope. So there's a lot of different ropes, and there's a lot of new ropes that have come out in the last few years. Essentially, any rope between 7.5 or 8 millimeters and 11 millimeters is perfectly fine for glacier travel. These are ropes that are more than strong enough for the kind of loads you can expect. We're not going to do technical climbing where we generate high impact forces if someone was to take a serious lead fall and go for 10, 20 meters before the rope caught them. These are situations where an individual falls into a crevasse, and if the rope is reasonably tight, they're really not going to pick up more than half a meter or a meter of travel distance before the rope catches. And then the second or the third are going to start getting pulled. So it's also a very soft dynamic impact. These don't generate a lot of impact forces. There's also some new ropes. The new 6 mil static ropes are amazing. They're really thin. They're as strong as a climbing rope, so you got lots of margin, and they're light. A 6 millimeter rope weighs nothing compared to a 10 millimeter climbing rope. But for the purpose of my discussion this evening, for the most part, unless you have some questions, I'm happy to go there. I'm going to talk about 3-person teams, and you'll see why shortly. And within a 3-person team or even a 2-person team, we recommend the minimum length for the ropes should be 60 meters. If you buy a 60-meter rope whether it's a climbing rope, a half rope, a twin rope, or a hyperstatic rope, you're going to have enough rope for a team of 2 and a team of 3 to be able to perform a proper crevasse rescue. If you bring the rope down to a 50 meter, surprisingly enough, a 3-person team can do a proper rescue with a 50 meter rope. But a 2-person team actually has to start doing a variation because they don't have enough rope. It seems a bit backwards, but a party of 2 needs more rope than a party of 3 because they have to carry everything they need for rescue. And because they're spaced out from the middle, they're actually taking a bit over 50% on each side, which kind of messes up your numbers. Whereas a party of 3, center person is always in the middle, so half the rope is always on the surface, no matter what. At a 40 meter rope, it's still possible to do a rescue and travel safely with a 3-person team. You can't do it with a 40. You're going to have to make some modifications. And what the manufacturers recommend is carry a 30 meter rope. Okay, so you've got a 40 meter rope for 2 people if you're trying to save weight. But then you have to carry a 30 meter rescue rope at each end. Or, if you're careful, you might just need to carry a 30 meter rope at one end, but that's 70 meters of rope. Again, a 60 meter is lighter. So a 60 meter is a really good, reasonable distance, or reasonable rope length to be working with. And then how far apart do you spread each person on a rope? It's going to depend on basically what the group is, it's going to depend on the number of people on the rope. If you have a party of 3 or more, then you can go with 12 meters for a party of 3 and less as your numbers increase because you've got more mass on the surface. If there's just 2 people on the rope, we recommend the minimum distance is 15 meters. So it's more. That gives a second greater time to come to a slow and stop the leader falling in. So again, party of 2 needs more rope. Party of 3 can get by with a bit less because you have more mass on the surface to hold the load. And as I said, the guidelines I'm going to talk about today are intended for a party of 3. Now, when you're measuring a rope to figure out how to put everybody on there, what we often do is we'll basically measure the rope by pulling our arms out and counting how many pulls it takes. And that's a good technique. Find out how many pulls it takes to get a 60 meter rope. And for me, it's about 33, 34. But if you want to really be able to spread the rope out nicely, what you do for a party of 3 is you go straight to the middle of the rope, tie a knot there, and that's where the second is going to clip in. And then you measure out the equivalent of 12 meters. So for me, I think that's 8 pulls. But you need more rope than just 12 meters because we added additional knots in between each person. And this is new. They're called moose knuckles. And let me show you a little bit about that. Whoops. Did I just go by 2 pages? There we go. Knots and hitches. Basic crevasse rescue, if you want to keep it simple, you need to know the overhand knot and the overhand knot on a bite. You need to know a prusik, which is a hitch, and you need to know a moose knuckle, which is a new rope, or a new knot. That was developed to work as a friction knot. So first of all, the difference between a knot and a hitch is when you tie a knot, it basically just exists on the rope independently. If you tie a hitch, it has to be built around something else, a carabiner, another piece of rope, and if those are missing, it falls apart. So hitches have to be made around something, whereas knots will stay in a place. I think everyone knows the overhand knot. The prusik is pretty simple. And what's really important, though, is when you're tying knots, you consume rope. And we're now tying knots in between the first, the second, and the third. And the reason for that is for friction. So you go 3 meters from the first person, and you tie a knot in the rope. Then you go another 2 meters, and you tie a knot in the rope. Okay. Then you go to the middle of the rope, and the center person goes 3 meters out towards the first, ties a knot, then another 2 meters out, ties a knot. So there's 4 knots between the first and the second. And then you do exactly the same thing between the second and the third. And this is where the moose knuckles come in. Okay, so just so we're all on the same page, here's an overhand on a bite. It's a loop. Whenever you make a bite, you make a bend in the rope. Just feed it over itself, pull it through the loop. It's our simplest knot. There you have it, the overhand. Next. Whoops. The next knot is the prusik hitch. And the prusik is not the easiest way to basically secure one rope onto your main line or your climbing rope and allow you to pull. But it's very reliable and it works under every circumstance. So that's why I use it. There are devices you can use, like a T-block, like a ropeman, all sorts of little gadgets. But the truth is, if you drop them, you're going to want to know how to do a prusik. So by all means, go ahead, learn the toys, play with them. If you want to know how to do a backman or some of these other climb heist, different kinds of hitches, that's fine. But just understand, the prusik works without any additional tools, and it's the only hitch that will bite onto a rope in both directions. So while it might be a bit of a hassle, it is the one hitch that'll always work. And the nice thing about it too is when the force exceeds its ability to bite, it slowly slides. So there's no catastrophic failure. And once the excessive force is reduced, it bites again. So there's your prusik, and as you pull, it basically grabs and holds onto the rope. This is necessary for basically transferring your weight or transferring the load onto a different rope. Okay. Then finally, a moose knuckle, and this one's new. And a moose knuckle is actually very simple. So you take a piece of rope and you tie an overhand knot on a bite. Overhand on a bite. Very simple. Okay? However, you don't just tie an overhand. You now split the knot, put the loop of your overhand through, and then just feed it through one of the bends in your knot and cinch it up. So really all it's doing is making a mess of the rope. And the overhand is a friction knot. And we use friction knots so that when the leader or the second or the third falls into a crevasse, if there's sufficient snow, and there probably is, because you wouldn't fall into a crevasse in a thin snowpack most of the time, those knots are going to bite into the snow and they're going to create a tremendous amount of friction. And that is really important. Let me show you why. Why do we need moose knuckles? Check this video out. It's absolutely terrifying and a really good introduction as to why we need moose knuckles. It's coming, trust me. There we go. Very dramatic music. I don't know why, but it always starts where I last left it. I'm going to drop that volume down a bit. So this is a group, I think they were out of the Czech Republic, and they were testing how effectively one person can hold another falling into a crevasse. Check this out. It's really terrifying. Now, in every case, they had an anchor, a backup anchor, and in every case, they needed it because the second couldn't hold the first. There you go. He went right to the end before the other guy caught him. And some of these guys just were flying. This is not a good sign. You start to see why we had to change our systems. What we're discovering is if you sort of use traditional techniques and you didn't spread too far apart, two on a rope really didn't work. And from personal experience, I can tell you I did have to hold someone, walked off the Bergschrund in a whiteout. I did manage to hold him, but I'll tell you, it hurt like you wouldn't believe. And there was probably as much luck as skill. I was also talking to another person at the Alpine Club, and he too has held someone who went into a crevasse. And he said he managed to do it, but he was unable to hold him until literally he reached the very edge of the crevasse, and just by luck there was a lot of snow there and he got stuck in the snow. So it could have just as easily gone to disastrous. Two people on a rope is tough. And in many situations, it might not work. This isn't good, to say the least. And I really appreciate some of these organizations starting to look into this. Because as I said, there's really... Okay. That's what I need to do. There's very little research being done on this. However, the French have begun to do some research, and they're the ones who invented the moose knuckle. So I'll show you their research and the video to match it, and you can hear them describe it.
At the equipment testing facility at the guide school, we study safety issues which concern mountaineering. Some tests are too complex to be done in a testing center, such as studying how much force is generated during a crevasse fall, for example, because we'd have to take into consideration the friction of the rope running through the lip of the crevasse. So we go out into the real world and do the tests in the mountain environment. We decided to carry out these crevasse fall tests at the Col du Midi above Chamonix. We wanted to measure the effect knots in the rope would have on the mechanics of holding crevasse falls, and also the effect of the distance between each person on the rope.
D'un côté, on va faire tomber une masse.
We're going to drop a weight onto a rope without knots, and then, under equivalent conditions, onto the same rope, but this time with knots. We're going to measure the force which would be exerted on the person holding the fall to see if there's a difference.
Différence de force engendrée sur la personne qui retient la chute, selon qui est des nœuds ou qui est pas nœud.
Test 23, 3, 2, 1, go!
We designed this pulley system in order to replicate the action of the belayer who's sliding, being dragged forward by the person falling into the crevasse. It worked perfectly. We tried to simulate the action of someone who's struggling to hold a crevasse fall. We estimated they'd have to counter a load of about 80 kilograms. We're able to replicate this sliding action with the same intensity each time, using a weight of 80 kilos over a distance of 4 meters. The system simulates the belayer progressively braking and holding the fall.
Alors, test au 34, joker avec des nœuds et système de freinage. 3, 2, 1, go!
Alors les manipulations d'avant, on a fait qu'une...
So we did the tests initially with this pulley system, allowing us to progressively hold a fall with 80 kilograms until the knots engaged with the snow. Then I did it for real, sliding for 4 or 5 meters until the knots dug into the snow and held the weight. In real life, the belayer would then be completely free to make an anchor and start the rescue procedure, without being pulled forwards by the person in the crevasse, and without the rope being continually under tension.
Sans être sous la pression de la corde du shooter. Ah bah si, tu vois.
Si tu vois, regarde.
No, look, it's worked. The knots have held.
Les nœuds ont marché.
And the backup rope slacked too, so I wasn't held by that.
So we successfully tested our system of simulating someone holding a crevasse fall. And of course we also tested the effect knots have on the difficulty of holding a fall, and they proved to be very effective. They're not effective in every situation, however. Last year we did similar tests, but with just 30 centimeters of snow above ice. This wasn't enough for the knots to properly dig into the snow, and in those tests the knots didn't work at all. We got the same results with or without knots. The knots simply slid on the ice and didn't properly penetrate into the snowpack. If the snow cover at the lip of the crevasse is a meter and a half deep, Then the knots are pulled deep into the snow and end up blocking the rope. Our tests validated the effectiveness of this technique, and we strongly recommend climbers use it. So the results of these tests with a single rope demonstrate that the knots were effective each and every time they were used. At the end of the fall, there's a maximum force of between 10 and 20 kilos on the belayer, which means that it's very easy to hold the person who's hanging from the rope. This obviously makes the rescue procedure a lot safer. With thinner double rope, the results aren't quite as clear, but there's still a big reduction in the load exerted on the person holding the fall, which is very important. In the conditions we worked in, with thawing snow which was heavy and really quite dense, we strongly advise you to tie knots on the rope. The test showed that 3 knots were easily enough to reduce the load on the belayer. There's no point in tying more knots than this, as it will just use up a lot of rope. We recommend tying a knot 3 meters from each person, and then another 2 knots at 2-meter intervals. We tested several different brake knots. Brake knots should be big and bulky so that they break effectively as they get pulled into the snow. They should also use as little rope as possible. Some knots cause the rope sheath to tear when loaded with a force of 6 kilonewtons. So you start by making a classic figure of 8 knot with a loop which is big enough to go between these two ends and back through the wall. With thin ropes, the knot's not going to be bulky enough, but you can make it bigger by passing the loop behind again and back through the main loop.
Okay. So a couple of things about this is currently they seem to, from what I've read and seen in various papers, is 2 knots from so 4 knots between each person, 3 and 2, 3 and 2 seems to be fine. And in Canada, for some reason, we're using the overhand knot, not the figure 8. And this does use a bit less rope because these knots are very, very rope intense, or they use a lot of rope. A single moose knuckle, which is the one I showed you, basically consumes about 1 meter of rope. So every moose knuckle takes 1 meter of your rope. So if you're planning to have people, you've got a party of 3, 12 meters apart, 4 moose knuckles, you need 16 meters of rope between 2 people to tie them. That's basically with a 9 to 10 millimeter rope. With a 6 millimeter rope, I found that it took about 0.6 meters to tie a moose knuckle. So it's a little more than half. They aren't as thick, they're not going to be as much friction, but they do help. And I was curious because this is really the only study I could find where they actually looked at how effective moose knuckles were. And what I found is when I was doing crevasse rescue courses, I brought along a scale and I could measure forces. So I couldn't measure the kind of forces that people would generate falling over the edge because we didn't have the equipment. But once they were over the edge, if we had moose knuckles, I would then measure the force necessary to keep the person from falling farther down. And a 100 kilogram load, so a person who weighed 100 kilograms with all their gear on, required a force of just over 20 kilograms to hold them in place. So 80% of their load was absorbed in the snow. If you looked at the graph where they showed the force during the fall, moose knuckles with a thicker rope did help reduce the initial impact and then greatly reduced, almost eliminated the need to hold the victim. So they were very, very effective. Thinner ropes, the party got more of a hit. And this is why if you're just traveling with a party of 2, going with a thicker rope does give you a real advantage, but also understand that the initial hit might actually be pretty close to the same as without knuckles. Once the rope starts to sink into the snowpack and gets a bite, then it makes a real difference, and holding the person's a lot easier. but the initial force to stop the fall will still be pretty severe. And that's why, again, at this point, I'm recommending, if you're just getting started, go with a rope team of at least 3 people. Once you've got some experience, you've actually practiced this and held some real loads, people who could jump off a steep roll that had a good landing or a nice gentle slope that allowed them to transition if they couldn't be held, and you could practice feeling what it's actually like to hold somebody, then it's probably not unreasonable to go as a team of 2. But until you've actually held that weight, it's amazing just how hard it is. Okay. So moose knuckles are really important because they make our lives a lot easier. And there's been a lot of people who have had to call for rescue traveling on a glacier because they simply didn't know how to get somebody out of a crevasse once they fell in. And that's largely in part because we don't have standards to get them out. And when you're looking at the old books, Mountaineering, Freedom of the Hills, even some of the material put out by Petzl more recently, and a lot of the other books, they don't account for moose knuckles. And as a result, you can't get them out the way we used to think you could. So that's important. I'll talk about that in just a few minutes. But before we get there, when you're going on the glacier, what's the criteria for even putting a rope on? It's actually pretty simple. Anytime you're uncertain, put on the rope. It's not that difficult, and it does buy you a margin of safety. So use the rope. And it should be everyone who makes that decision. If someone's not comfortable, put on the rope. If everyone's comfortable with the decision, great. But all you need is one person who's really not sure we want to take it off. Keep it on. There's no downside to keeping the rope on. Because to be honest, if you're in a situation where you have multiple hazards, it's not just crevasses, those hazards are going to exist regardless of whether the rope on is not. The rope might increase it, but you're also eliminating any protection from another scenario. And what you really need to be asking yourself is, should you be there? Because you're stacking a lot against yourself. So be careful. I understand there's times when you might think it's better without the rope, but what is it that's got you so scared you don't want to put a rope on? And at that point, is it still reasonable to be there? Okay, so if you're in doubt, put on a rope. Put a rope on if you're on a glacier or an ice field. And if you're not sure, put it on. The only fatality I've ever been involved with was when 2 people didn't even realize they were on the glacier. And unfortunately, one of them fell through. And then we worked on a body recovery. So when in doubt, put on the rope. How deep is the snow? Put the rope on, start moving through the snowpack, and as you're probing, if you're constantly getting really good deep snow, and I mean over 2 meters of probe, consistently, over the span of half an hour or so, in different regions where you're going up, you're going down, areas that have wind effect, areas that look like they might naturally be thin, and you're probing and you're still getting more than 2 meters, that's a good sign. I wouldn't take the rope off yet, but it's a really good sign. And then, if you can see, you've got a clear day, you've got good shadows, are you seeing sort of those natural sag-likes or ripples, very, very consistent large ripples in the snowpack that suggest you have sagging crevasses? If you do, then you'll probably keep the rope on. You have a concern. What if you can't see? If you don't have good visibility, even if you're getting good depths, you know what? It is so hard to know what you're up against. I can't tell you how many times I've heard of guides getting injured because they're in a whiteout and they're leading the group and they literally just ski off a little cliff. I've done it twice. Fortunately, when the weather's usually that bad, it means there's a lot of snow, so you probably have a soft landing, but not always. So if you really can't see well, keep the rope on. Another thing to consider is your familiarity with the region. If you've been going into this area fairly regularly, you've got good information, and all the other things are very positive, that's great. If you're coming in cold, then you probably want to keep the rope on until you've had time to gather more information, because it takes time. And this is why sometimes you'll see one party put on a rope and another party not, and they're both making the right decision. The group that isn't putting the rope on might actually have a lot of good information because they've been on that route substantially over the last few weeks. The party that's putting it on just doesn't know yet, and they need to gather information. And it's always good to decide for yourself, when is it safe, when is it appropriate? Don't let another party decide for you what the right decision is. Okay? So those are all very important factors. Gather them up, talk to the group, and decide. Okay. That's when you want to put the rope on. So here we are wandering off into the white. Got our moose knuckles on. Put the rope on if there's any uncertainty. If you're just not sure, put it on. You got nothing to lose. If your visibility is poor, that is pretty flat light. We can't see any of the texture in the snow. It's also a thin snowpack. Right now it'd be huge, but you know, at the time of filming, the snowpack was only 40-50 centimeters. And if you're seeing crevasses or sags, then that's another concern as well. Your default position should be put on the rope. And remember, it's 12 meters apart for a team of 3, 15 meters apart for a team of 2. If you're in bigger country or you have other concerns, make it wider. Go right ahead. You can always expand, but we recommend nothing less than those measurements. And then the only way to know what you're up against is to actually feel the snow. So get your probe out and probe ahead. When I first started out, I just probed right under my feet, which basically meant, have I already gone too far? It wasn't the best move. So probe ahead of where you're going, and that way you know what you're stepping into. And after a while, you'll have good information. You can start to say, yeah, this is reasonable, or, you know, maybe I need to keep the rope on. Or, geez, there's a lot of slots here. Maybe I need to change my course. Gather the information. Okay. So basic equipment. If you're going to go up on a glacier, you got to carry toys. And boy, you look at all the reports and everything, you need a lot of gear to go on a glacier. No, you don't. This is the base minimum, if you're a 3-person team, that you should have for traveling on a glacier. If you've got a pair of skis, because you'll need them for an anchor, you should carry, at a minimum, 1 triple action locking carabiner with a spring gate. And that is so you can clip into the rope. There is a way to tie into the rope, but again, it consumes line. It's a bit of a hassle, and so, you know, most people aren't doing it. There's a concern with a single locking beaner. If you cross-load it, you know, for some reason, your rope's just lined up sideways. Apparently there has been one case of a locking beaner failing from a sideways pull. And that's why the spring gate, which is that little spring thing you see right over here, helps keep this sort of pinned nicely. And then the main rope is here, harness is clipped in back here, and that way this unit won't cross-load. Regular locking beaners, take 2 of them along because you're going to need them for basic rescue. Take an ice screw. You're probably not going to need it, but you want one. Everybody in the group should have an ice screw. The leader has an ice screw, so if they fall into a crevasse and they're not sure the surface team is able to hold them, they can probably get an ice screw into the sidewall, clip into it, and anchor themselves. A friend of mine actually saved his life doing that. His partner couldn't hold him. They were a team of 2. If you're the second on the rope, the leader goes in and the snowpack is fairly thin, you may not be able to build an anchor. You got to go to the ice. Fine, dig down to the ice, put in a single ice screw, and then stay taut on the rope, and when the third comes up to join you to work on the rescue, take their ice screw, put in the second, and now you've got a really solid anchor. So it's worth having. We've just used up everybody's ice screw. And then finally, take 2 cords, and there's a lot of variation on this. You don't need to take these, but it's pretty reasonable to have, as a good standard, 2 5-meter long 7mm cords. If you take a 7mm cord and you double it up, it's as strong as a 10mm climbing rope. So that's why we choose 7. If you're traveling with one of the 6-meter hyperstatic, you probably need a 5mm cord because they have to be the same or smaller diameter in order to bite. And also play with the cord because the stiff cord really doesn't bite well for a prusik, but there are soft cords out there and they do beautifully. You can also do variations like a T-block and a ropeman and various things, or you can use the, what's that thing called? The auto block. They all work fine, but they're specialized tools and they don't work in a lot of variations. This simple combination gives you a lot of variety and it's cheap. Okay, that's what every person on the rope team needs as a minimum for traveling on a glacier, for rescue. Okay. So whenever you get into a situation where you're doing rescue, there's 5 steps, and it's a consistent 5 steps. Whether you're doing glacier travel or a lot of rope rescue systems, we go through these 5 same steps. And so this is why I keep pounding them, is because you're going to use this if you're into mountaineering or alpinism or rock climbing. They're very similar, even caving. So the very first thing you got to do is stop the fall. Then you need to build an anchor. Then you have to transfer the load from you holding the fall to the anchor. So suddenly the load's off of you and you're free. Then you assess and determine the appropriate action, because usually you know what you're up against, but sometimes there might be choices. And then finally you make your decision, you act, and you get the victim out. You extricate them. Simple enough. Okay. So for the term of this process, I'm going to call the person who falls into the crevasse either the first or the victim. The person who holds the fall is the middle or the second. I use the term second. And at the far end of the rope is the third. If you split the rope so the first and the third are carrying the extra coils of rope, then they can switch back and forth and take turns with breaking trail and leading. The middle or the center is always the middle or second. When I talk about rescue, the main line is the one, pardon me, that the rescuers are holding the victim on. So the victim is swinging in a crevasse with on the main line. And then you need a second rope to initiate the rescue. That's the rescue rope. The rescue rope can be part of the same rope that the victim fell in on, just the coils on each end. I still call that the rescue rope. Or if you want to carry a second rope, go right ahead. Problem with carrying second ropes is now you're needing more and more and more ropes. I like to just keep it down to 1. But sure, if you're really into it, go ahead. Take some extra rope. So the rescue rope could be either the main line, or it could be a separate one. It really doesn't matter. And then everyone has a duty when you arrest the fall. And I'll go over that in a second. Actually, maybe a couple of minutes. So once the victim falls in, everyone has to first arrest the fall. And that involves the second basically being launched by the force of the first person. But that's a good thing, because they're absorbing a lot of energy and just slowing down the process, which means the third isn't going to get hit nearly as hard and be in a much better position to start taking up the load. So the second is the shock absorber, and the third is the one who's able to sort of position themselves and hold the fall. This is why it's nice to have 3 people on a rope, because you saw those 2 people going into the crevasse. It's really hard for 1 person to hold a fall. 2 is a lot tougher to move. Good. So once you've had the fall, then you're going to build the anchor. Oh, sorry, I'm ahead of myself here. The second builds the anchor, so they're closer to the victim. That gives you more rope. Some of the videos I've seen have the third building the anchor, which is kind of crazy, because that just makes you a lot farther from the victim who you're going to be hauling out. And remember, the rules have changed. If you're using moose knuckles, friction knots in the rope, what you've done is you've greatly increased your ability to hold somebody who fell into the crevasse. But there is no way you can winch them out, because moose knuckles work both ways. They hold the victim through friction from going deeper and absorb a lot of the energy, and they will fight and try and stop you from pulling the victim out using the same rope. So traditionally we never use the same rope anyways, because it's cut into the snowpack, which could easily be 1 meter or more, and that alone would make it very difficult to haul the victim out. Plus, somehow you've got to clean that lip so they don't get stuck coming up through that pretty nasty lip of snow. So the main line, or the line that the victim fell in on, is critical because it holds the victim. But it is not useful for rescue anymore. Don't even consider it. Moose knuckles have made that impossible. So now the second builds an anchor, and they transfer the load. I'll show you the video for that. But basically, you dig in, put the skis perpendicular to the direction of pull, you wrap a cord around them, tie off the cord, bury the skis, then you put a prusik on the rope towards the victim, away from the second, towards the victim, and then you clip that prusik cord into the anchor point, which we call the master point, and the third slowly moves forward, puts the weight on the skis, and now you're in a position to start a rescue. Okay, that then allows you to assess the situation and decide on your rescue. In most cases, we're going to extricate the victim. And if you have two people on the surface, you can just do something as simple as just dropping a loop of rope down. One end of the rope is secured to the anchor, so if you're using the same rope that the victim is on, just the extra rope out of the third can be used to reach down to the victim, and then the two pull the victim up, the second and the third, and because it's a loop, it is a 2-to-1 mechanical advantage, and it also is the most efficient system we have to get somebody out. And the reason it's the most efficient is because it doesn't run through carabiners going back and forth, because every time the rope moves through a device, there's friction, there's resistance, and it becomes less and less efficient. 2-to-1 is hard, but most of your energy is going to get the person out of the crevasse, as opposed to being lost in resistance through the rope. Having said that, friction is great if you're a moose knuckle, because it helps hold the victim. But it's really bad if you're trying to get the person out of a crevasse. And so this is the other thing we've discovered, is we have to be really clean with how we bring the rope down, make sure there's no twists, how it comes up and back to where the rescuers are going to pull them out. Because if the rope is running through the snow, and with any kind of pressure, the friction it builds up is huge. I let a group put together a basic drop loop after the victim was in, and the victim weighed 80 kilograms. And then we hauled them out. And again, I put a scale on it and we measured the force, and guess what? Even though it was a 2-to-1 mechanical advantage, so the 80 kilogram person should have been 40 kilograms to get out, because I let them build it without being careful about friction and resistance as it goes through the snow and over the lip. The actual force with a 2-to-1 mechanical advantage, it was 120 kilograms of force to pull an 80 kilogram person out despite the mechanical advantage. So that's crazy. And that's because the snow was cutting along the edge and the snow was cutting through the snow a bit. It builds up fast, and that's huge. So be careful. I'll show you. So if you're the first, you're a party of 3, and somebody falls into Vark Tech. I'm not sure what that means. You're a party of 3, and the leader falls into a crevasse. Okay, so here I am. I've fallen into a crevasse. This is not good. What do? Just sit there and wait for a rescue? The old school of thinking you can prusik out of a crevasse is still possible. But remember, if you've gone down a little ways, there's going to be knots in your rope, and you're not going to get your prusiks past the knot. You can work your way all the way up really close to the knot, then basically tie a clove hitch or another knot, clip into that with your harness, hang on that, and then take your prusiks off, move it above the moose knuckle, and continue prusiking. But the truth is, it's really hard. The other thing is it's impossible to prusik with your skis on, and it's really hard to prusik with your pack on. So my first advice, if you ever fall into a crevasse as the victim, is this. First, just clip your poles onto the rope. Now your hands are free. The next, clip your pack on, because the pack's going to keep pulling you upside down, and that's just going to take a lot of energy. Now you're hanging in a crevasse and you're actually pretty free, so you can think about what you're going to do. If you have any doubts about the group being able to hold you, take your ice screw, screw it into the ice, take your prusik cord, clip it into that carabiner, tie it off on your harness. Otherwise, just wait till the rescuers arrive, they drop a rope down to you, and they pull up the pack. And you can leave the skis behind if you want. Take out your prusik cord, clip it on to one of your skis. I've got a little piece of string tied to the toe on my binding, so I can put a carabiner on it. Because if while you're trying to take your skis off, you drop them, they're now lost in a crevasse. So that cord is really important. Wrap up your ski poles, pull out a ski strap, and just wrap it up the way we normally wrap skis, as if they're going into a ski box in the car, or just the way we normally pack them. Now the skis are out and you're free, if you can, to try and prusik out. they don't need to do a rescue if you can prusik out. Again, the moose knuckles make it really tough. So don't consider this old school concept of getting yourself out of a crevasse. If you have to, you have to. But understand that it's really difficult. And you're going up the rope that is cut in deeply into the snow. I've tried climbing ropes that have cut it into the snow. Even without the moose knuckles, I have about a 50-50 success rate. Half the time, I cannot get through it. The other half of the time, it's really painful and ugly, but I do eventually manage to kick through the top. What seems to make the difference is if I've got enough snow to start kicking my feet in as I get over the lip. So in a thinner snowpack, it's actually a lot harder. In a deeper snowpack, I can kick my feet in, and I can just punch and dig my way around through that ugly overhanging lip of snow. Not always. It's really painful, but it can be done sometimes. Much better, get help from the surface. That's why you brought your friends. So that's the leader's job in a crevasse rescue. Here's the second's job. So we're looking at the middle person. The leader has fallen. I've fallen into a crevasse, and she has basically taken the hit. And then as soon as the third is able to help hold and stop the fall, she goes into position where she can help and begins building an anchor. So as soon as the second knows the third has safely got the load, she can take her skis off and she can begin to build the anchor. You can see the line to the victim and to the third. There we go. Measure it out. Grab your shovel, and yes, this can be done on a rope, but it's tough. And it's kind of hard to see. So I cut back and forth with digging in the anchor without. But yeah, dig a T-slot. You've got to dig down to get into firm snow. And of course, what is firm snow? Firm snow is basically if you take your index finger and you push it into the snowpack, when you start to feel resistance, that is, it's just enough that you want to bend your wrist, that's firm one finger snow. If you can get into stiffer snow, great. But you definitely want to have it strong enough to do that so that you know your skis are sufficient. Now, once you've dug out your slot, just wrap some cord around it. The 5mm prusik cord is great. If you want, you can buy a sewn sling. They're lighter and they're stronger. But again, you know what? You got to remember to have a long sewn sling and have it handy. This way, you know exactly what you've got. It's your call. Sewn slings are easier. They are stronger. Make sure you get the longest one available, which is 1.8 meters. And you've wrapped the edges of your skis with a hat or something so the metal does not cut the rope. There. And you dig it out. This is why we call it a T-slot, because you've got to create that sort of T feature for the rope to come out. And the place you want the rope to bind on your skis is in between the toe and the heel, and just a little ways behind the toe. And that way you're pretty much at the center of the ski, and that's where you're going to get maximum strength. If your skis don't have brakes, throw on a ski strap just so they don't split under a heavy load. Then you pack it down to make it even stronger. And it's impossible to avoid it, but as much as you can, minimize the disturbance of the snow in front of the anchor, because that's what's holding it. Then when you tie this, if it's a prusik, that's called the master point. If you've got a sewn sling, don't bother tying it because you've already got a loop. Clip a beaner into that, and that is your master point. Once you have that master point, just sit down facing the victim and put a prusik on the rope. Simple enough. Again, yes, you can use a T-block. Yes, you can use a climb heist, a auto block, all sorts of things. But you know what? Those are specialized. You're going to need to have those pieces with you. I like to keep it stupidly simple because in my whole life, the only time I ever had to winch somebody out using crevasse rescue was actually in a canyon. They couldn't get up the rope, so I just switched to crevasse rescue and hauled them out. That's over 40 years of traveling in the mountains. I have held a couple of falls into crevasses. We didn't have to do any special rescue. It was just either a quick pull or they got themselves out. So there's the master point, the anchor, and I clip it into the prusik that I've just tied. Then you cinch up the prusik And the second and the third, just take a step forward. So now we're just moving a little bit forward, and we're transferring the load onto the anchor. And if it works, great. And if it doesn't, the second and the third are still nice and close, and they can catch the victim. If the anchor falls, they don't go very far. But we don't trust a life to a single prusik. So now the third walks up a little farther, the second can tie an overhand knot, takes another carabiner, and clips it into the anchor on the master point. As you can see, works pretty well. So now if the prusik slips, it's really only going to go half a meter before it gets caught on the main line of the rope. Okay, so that's pretty much everything the second has to do in a crevasse rescue. And the third, let's see if this works, because I just put this together before the video. I didn't have to check, but haven't have time to check most of it. So we'll see how many flaws I've got. So this is the choice of the third, the person at the back of the rope. So they're holding the fall. They arrest the fall. Oh yeah, got that doubled. So once they've arrested the fall, they basically hold the weight while the second builds the anchor. But while the second's building the anchor, they can put a prusik on their rope. And they then tie the prusik into their harness. Don't use the locking beaner, use the loop in the harness itself. That way, if you unclip from the system, you're still connected to the rope. Or you unclip from the rope, you're still tied in to the prusik. That sounds better. Don't make it very long. You want to be able to easily reach this if it gets loaded, because this is going to be your self-belay system later. So while you're waiting for the second to build the anchor and transfer the load, you want to get your probe out, because you're just sitting there holding the weight. And then when the second says you can step forward, make sure there's no crevasses, and take a step forward, and you can take the weight off to transfer the load. And once they say, yep, it works, they're going to take a little more rope and they're going to tie in the anchor. Remember that part? And now you, as the third, are going to prusik up the rope. That's your self-belay. Probe to make sure there's no crevasses, and prusik. And then when you get to one of those moose knuckles, you stop and you untie it. Because this rope between the second and the third is going to become part of the rescue line. And once you reach the second, you do the handoff, and the third continues to probe as they move forward. And if it's safe, and they're making sure it's very safe, he just slides his prusik up and protects himself. So that's why the moose knuckles were taken out, so we can slide up that rope, and now we can slide past. And that's part of the rescue rope. With a 60-meter rope, the second is at the middle of the rope, and that leaves you with 30 meters of rope to go to the victim. Okay, so here we are reaching the edge, and now the third is probing to find out exactly where the edge is, because you don't want to fall into the crevasse yourself. You know there's a hazard. And once you've got it figured out, you can stop, prusik up close to the edge, and then you're going to tie something called a stopper knot. And a stopper knot basically makes sure that even if the prusik was to slip, it can't go past the knot because that'll jam it. It's a jam knot. So the stopper knot prevents you from falling any farther than that if the edge was to collapse and you're close to the edge of the crevasse. Okay? So it's your safety, it's your backup. Because now you're going to be busy. Once you figure out again where the edge is, and I can remove that footage because I don't need it. And you dig out your shovel. And with the shovel, you've got to really make a sincere effort to clean the lip. You want to make sure that there's a nice, easy ramp for the person to get out of, and you also want to build a mound right there above the height of the snow. And this is to reduce friction. This is really important because what it does is it gets the rescue rope out of the snow and changes the angle so it's much easier to pull the victim out. If you don't, you're going to get your 80 kilogram victim turning into a 120 kilogram pull because of all the friction in the snow. But if you put the pack up, and here I am just pulling up the backpack, and pretty soon the skis, but when we pull the victim up, what we found is if you do everything possible to reduce the friction, get the rope above the snow and don't let it run in the snow, use your pack, or better yet, use your ski poles. If it's really solid snow, you can lay your ski poles and they work like rollers. That will actually reduce the force from the friction dramatically. Once we tried to haul the 80 kilogram person with a 2-to-1 mechanical advantage using as much friction reduction as possible, they were 60 kilograms. Still not great, but a lot better because that was 30 kilograms for each person to pull. If you're old school, that's about 66 pounds. Most of us can haul that kind of a load with 2 people. 60 kilograms, yeah, so that's 60 kilograms is about 140 pounds, about 70 pounds each. Anyways, it's reasonable. So anyways, once you've done that, you've brought all the gear up, you have the victim clip into the loop, you go back and you make sure you hang on to the end, then you pull up all the slack, tie an overhand knot, clip it. So now they're in a closed loop. Take that closed loop, and it doesn't matter where, you put a prusik on it. And the reason you put a prusik on is so as you pull, you can use the prusik to capture the slack. And that way, you effectively prevent the person from falling in if you were to slip. So now they've got a prusik, a closed loop, and they get ready to pull. Pull up the slack, they pull hard, and then he slides the prusik up there. And if they were to slip, the prusik will catch the victim. And again, they come up, and if you need to tie in some handholds or something, go right ahead. Pull back, there. It's not easy. That person's fighting. But they're able to move them up. And that was about a 100 kilogram person. And they pull. And then you slide the prusik up. So she's holding it. He slides the prusik up. And now with all that extra rope you've pulled up, you can just tie a giant overhand knot. And that way, if the prusik slips, they don't fall all the way back down. So this is the way you sort of back things up. Okay. It's not easy. Practice it. It's good hard work. Lots of fun. So there she is. She's actually tying another handhold so she can pull more effectively. Go right ahead. But at some point, you're going to have to tie a giant overhand knot just to suck up that extra rope. When you get the victim close to the surface, what you want to do is make sure that you go slow. Because despite how long it seems to take, hauling somebody up is actually pretty fast. And they need time to get themselves gently over that lip. Otherwise, they could get hurt, or you're going to find there's a lot more friction going into the system. Okay? Does that make sense? So that's our basic 3-person rescue. And I think that's the end of my book. Let's see. Yep, that's the end of this. I'm just going to go back into the book I'm working with, and I can show you a couple of other things, because there is some cool stuff going on if you're into more complex systems. Okay, now, you can see this is a program called InDesign. Don't worry about it. It's just a program I use for desktop design. If there's 2 people on a rope, you have to be really careful because you can't use a basic drop loop for the simple reason you're not strong enough. You're going to have to build a better mechanical advantage. I don't have a video of it, but the Z pulley or the 3-to-1, if you've taken a course, someone's probably shown you a 3-to-1. And those work a little bit better, but once you get the friction into the system, they're no better than a 2-to-1. You'll get about 1.5 to 1, so that might work. You're probably going to have to build a more complex system called a 6 to 1. So basically the load is 1/6 of what they weigh. Sounds good, except it doesn't actually work that way. I did some tests, and what I found is if you did everything right, you put all the friction reduction systems you could. A 6 to 1, if you do it perfectly, might give you a 3 to 1 after all the friction in the system. And a 12 to 1 might give you a 6 to 1. But the truth is, you're probably with a 6 to 1 going to come in closer to a 2 to 1, a true 2 to 1 ratio. If you have someone fall in who's 80 kilograms, to haul a 40 kilogram load out is difficult but possible. If somebody goes in at 100 kilograms, if you're really strong, it's possible. But you're hauling 110 pounds out of that crevasse. So you're going to have to be a pretty strong guy. And remember, you got to be careful not to get hurt as well. So this is why two-person rescue is tough, and partly why Parks has so many rescues involving people who fall into crevasses. It's because the people don't realize how inefficient their systems are, and the course they took and the simple basic things they understand simply don't meet the demands of what really happens. So you want to practice them. And one of the biggest issues, it's coming in here just in a second, should find it, are these. When you're by yourself, you can't have two people pull and one person slide up a prusik. You need a ratchet where one person pulls, and when they let go of the rope has been captured. So they're called capture devices. And there's a whole range of different capture devices out there. In fact, let me see if I can pull up a video. I'll do that in a second. This is the Garda, and the Garda just uses 2 carabiners, and they have to run on a soft, whether it's webbing or rope, but they need a soft anchor. They don't work well on metal points. This is really simple. You only need to carry a couple of carabiners. I've used it in a couple of situations. It's a great improvise. The problem with it, though, is it's very, very inefficient. Inefficient to the point that if all you're doing is a straight pull capture from the rope or a 2 to 1 mechanical advantage, just because of the nature of the pull, these things are about 15 to 17% efficient. So what that means is if you're trying to pull 100 kilograms out, the inefficiency of this system, if you're just doing a straight 100 kilogram pull, you would have to pull 500 kilograms to get them out because there's so much friction. They're useless. If you work with a Z pulley, it changes it dramatically, and they become a little less than 50% efficient. So if you had to pull 100 kilograms out, you'd actually be pulling 200. Much better than 500, but still beyond what we can do. So keep in mind, you need really good mechanical advantages, and they only work with certain types of systems, not all of them. We've all heard of the the guides mode in the auto block system for ATCs and belay devices. Guess what? They work just about as well as the Garda. In fact, I think they were 1% worse or 1% better. It didn't matter. If you're trying to do a straight pull or a 2 to 1, these things just suck up all your energy through friction. They're horrible devices. But if you're using a Z drop and then building other mechanical advantages on top of that, they work reasonably well. And so they can be used for improvised rescue. But I wouldn't recommend trying to do a simple extraction using those systems. They are great improvised. This is just a traditional T-block, and right here you just pull the rope, then the T-block catches. It's a device made by Petzl. It's about 54% efficient. A prusik with a belay device, basically acting as a prusik-minded belay device, they're about as efficient as a T-block, just over 50%, or around 50%. Prusik-minded pulley is actually pretty good. It'll run almost as well as these things, the micro traction or the sprocks, which are made for this. In a real world load, like once you get over 40 kilograms or so, the sprock, the micro traction are pretty much identical. And the prusik-minded pulley is pretty much identical. This is my system of choice for complex rescue where I need a ratchet. because I can use these parts for various things. They're small, they're light, I can improvise if I need to, whereas this is a very specialized piece of equipment that I have to carry around. I really can't use it for much else, and they're fairly expensive. So by all means, these devices work, they're great. This works just as well, and it works on other things. It's less expensive, and I can use the parts for a variety of situations. I can also improvise with this, whereas I can't with this. Let me see what I got here. Crevasse rescue. Sorry, I'm just going into a video masters. There we go. MP4s. Capture efficiencies. Let's take a look at them. So here I am just doing a straight pull. That's a 25-pound weight, and at 52 pounds I don't want to pull the anchor off the roof or the joist, and at 52 pounds it's not moving an inch. With a Garda, same thing. I later tried these with other anchors, and it took huge amounts of weight or force to move with that. Here we are with the Prusik-minded belay device. 50 kilograms, or sorry, 25 pounds turns into 54 pounds. Here it is with the T-block. 25 pounds turns into 48 pounds. So not bad. See how things just build up? It's pretty much double. Prusik-minded pulley, it's 35.5 pounds. With the Sprock, it was only 27.5 pounds. However, when I used heavier loads, I found the Prusik-minded pulley and the mechanical capture systems were about identical. So Prusik ATC, T-block, these things are actually not bad. These guys you can use in emergency, but understand they're limited, and the Prusik-minded pulley and the rope capture are the best you're going to get for basic capture systems for crevasse rescue. I'm not going to get too much more into the complex systems just because there's so much to broach. But one thing I would like to mention, just because I'm in here, is anchors. There's very little data on snow anchors. And the reason there's very little data on snow anchors is because snow anchors are highly variable. We don't know how strong anchors are, period. It really depends on the snow. And when you build a snow anchor, let's see, do I have it in here? Okay, I'll just talk. When you build a snow anchor using skis, we know they'll hold a force of 8 kilonewtons, which is roughly 800 kilograms, a little more, which is pretty strong. Because a person swinging on the end of the rope with all their gear on probably weighs maybe 130, 140 kilograms. Okay, that's a big person and a lot of weight. In general, when we deal with mechanical systems that have people's lives on them, we're looking for margins of 10 to 1. So I really should be getting an anchor in that's 1,200 kilos. That's just not going to happen in snow. And sometimes, if you can't get good snow, it's a lot less. A pair of skis buried has a potential holding force of, in one finger snow, has a range of holding between 400 and 1,200 kilograms. That's a huge range. And so if you're into the softer layer of snow, but you're starting to feel resistance with one finger, you've got about a 2 or 3 to 1 margin in your anchor. That's not a lot. So we have to be careful with our anchors. Build good anchors. I was reading some test reports where a group in New Zealand and the States were collaborating to see how strong certain types of snow anchors were. And they were using really dense snow that you find in a maritime snowpack that's had the opportunity to settle and get really strong. The Rockies and the Columbias have much less stable or strong snowpacks. And so they were getting loads of about 250 kilograms off a bollard, which is a big horseshoe shaped feature that you cut in the snow, throw the rope over it, and the bollard was 1 meter across. And it held a force of, I think it was 250 kilograms, before the bollard cut through. Okay, so I tried that in the Rockies, and I didn't put a scale on it, but we built a bollard that was 2 meters across and 3 meters deep, and we dug it into the most solid snow we could find into last year's snowpack. 3 people pulling pretty lightly ripped right through it. Nowhere close to 200 kilograms. Another anchor we tried is they talk about bottles. A Coke bottle buried in really solid snow will hold a 200 kilogram load. Sounds pretty amazing. So we buried a bottle, Coke bottle that was full, sealed, put it as deep as we could, packed it down hard. 4 people popped it out, no problem. Well below body weight. Pickets, people talk about driving pickets in, and in the tests in the snowpack, they found that pickets in some cases would actually break before the picket ripped out of the snow. Again, it was a very, very dense snowpack. They were getting impact forces in excess of 600 kilograms. A pair of skis is thicker and stronger than a snow picket. And so keep those things in mind. When we're working in the Rockies, when we're working in the Columbia Mountains, we need to use skis. We need to use the biggest, strongest anchor in the most solid snow we can find. And if we can't get a good solid anchor, just keep digging and get your ice screw in. You don't need a long ice screw. Just the average, the mid-range ice screws for this type of work are more than strong enough. A single ice screw will hold about 700 kilograms. Okay? 7 kilonewtons. And that is plenty. Strong enough to hold the victim while the third comes up and you put in the second ice screw. The little shorties also hold quite a bit. What really matters is the first 4 or 5 centimeters of ice. If it's really good quality ice, cut through that loose, rotten crap, get into some good ice, you've got a solid screw. Go right ahead, put it on an angle to the direction of pull, because we're not shock loading these things. They're strong. 2 of them are great. If you're thinking you want to get into an ice thread, you can, but now you have to carry a longer ice screw because you need more space. You need a hook to get it through, and you must be on a pretty thin snowpack because you're going to have to dig down and then work on this ice thread. Standard ice threads are very strong. I would just put the ice screw in, but if you think you want to put a thread in, go ahead. A V thread, which is basically side to side, is pretty strong if you do them vertically. So if you make your thread actually in the direction of the pull, an A thread, A threads are 20% stronger because ice handles compression than pull or shear much, much better. In either case, you're building an anchor that's way beyond your needs. Just keep in mind, the anchor can't fail. So build the strongest one you can and be careful how you pull. I don't know if I'll see if I have a video of this, but this caught me off guard and someone mentioned it and I didn't believe them. So I tried it and lo and behold, they were right. Rope measure, where are we here? Ski anchor third, glacier travel, measuring the rope. Munter, overhand, Prusik, reusable. Okay, it's not in here, so it's in my other one. Garda hitch, fisherman's figure 8, clove. Capture efficiencies. 2-to-1 lift efficiencies. Measuring the rope, munter hitch, overhand follow through, overhand, Prusik. Releasable mainline, releasable cord. Oh, that's weird. Ski anchor, transfer load. I don't seem to have it here. Build the anchor, capture efficiencies. I've got 2 of those. One of those is probably what I'm looking for. Okay, but anyways, if you're pulling against the anchor, that is you're basically facing the anchor and pulling the rope towards the crevasse where the victim is, what you're doing is you're creating a 2-to-1 mechanical advantage. And sometimes it's easier because you think it's downhill and you're pulling the person up. But what's happening is you're actually creating a 2-to-1 mechanical advantage against your anchor. So if the person weighs 100 kilograms, you're going to have to pull 200 kilograms of force on the anchor. Even though you might feel it because of mechanical advantage, the anchor's load is doubled. And so if you have a weak anchor, you can blow it. Beyond that, you also have to pull for the friction. So if there's 20% friction on 120 kilograms, or 100 kilograms, you're going to be pulling 240 kilograms against the anchor. And if you've got your skis in relatively soft snow, you're actually reaching the point where you're close to where it could fail. So be careful on the direction of pull. I don't have the video, I apologize for that. But it gives you a sense. There's a lot more going on than we used to think about basic crevasse rescue and glacier travel. So by all means, take the time, figure it out, learn about what's going on, and read up on it. We are starting to do more and more research, but there's still a lot we don't have standardized yet for crevasse rescue. 3-person rope team or larger is pretty safe. You don't need moose knuckles if you have more than 3 people on the rope, because you're going to have so much weight on the surface. Use them. They're very effective for smaller rope teams. The new thinner ropes are great. Just understand their limitations. You can't use them for climbing or mountaineering, only for glacier travel, because they have no stretch. They could really do some damage if you took a leader fall on them. And then finally, 2-person rope teams get a lot more complicated really fast. And so take your time and don't just practice or read online how to do a rescue if there's only one person on the surface and 1 person in the hole. You're going to have to try these in real-world scenarios, in controlled environments. And remember, once you start accounting for friction and inefficiencies in the system, you're going to have to come up with something a lot better than sort of the basic Z pulley, which is a 3-to-1 mechanical advantage. You start at 6-to-1 and you build up from there. And if the person's heavy, you need a 12-to-1. And don't even think about trying to haul them out until you've got their pack and their skis out, because that's going to be a huge amount of friction and a significant amount of weight. Drop that and things get a lot easier. So really make an effort to reduce your friction, work everything out. And that's pretty much all I have for this evening. Any questions while I shut her down? No? Okay. Well, I'll stick around for as long as people are in. And thanks for joining me. The first 2 didn't go so well, but we got this one to work. That's great. Thanks, guys. All right. No questions? Okay. Well, have a good evening. Thanks for tuning in. Okay. All right. Good night, folks. I'm going to end the stream.